In this video, you're going to create the calculate size f function. So this function is going to be similar in structure to the one we used for folders. So we'll just copy the structure like that, and we'll change everywhere it says calculate size d to calculate size f. So let's delete the content of the function. We'll only return this array for now. And now let's check what parameter we're going to need for this function. So to calculate the size of a file, we will use the fs module of Node.js. So all we need is the start variable, which we created earlier. And we stored the value inside item details.stats. So that's the value we're going to pass to the function. Like that. So let's call the variable stats. And let's start with file size bytes. So this one can be obtained easily by going to stats and then size. So this will give us the size in bytes directly. So just one thing, if you look at the required files, we'll need to require the new file, which is calculate size f. So now we've got the size in bytes, and we need to convert that to the file size in human readable format. So you will need to write some code to do that. So to make things easy, I'm going to create a new file in the playground. And let's call it humansize.js. And here we're going to play with a function called math.log10. So the description says that this will return the base 10 logarithm of a number. So what does it mean? So if you try this on 1000, for example, and you console log the results, let's see what you get. So we're going to stop the app, and then I'm going to go to the playground, human size, and here you go, we get 3. So this means that 10 to the power 3 is this number, 1000. Now let's try with another number, 10,000. And we get 4. So this means again that's 10 to the power 4 is that number. Alright, so why do we do this? Well, at the moment we've got the size of our file in bytes, right? So let's say that the file size is 10,000, for example. And that's in bytes. And you want to convert this to a human readable format. Now to make things easy, I'm going to create a string as we did before. We're going to call it units. And here we're going to store the different possible units: bytes, kilobytes, megabytes, gigabytes, and petabytes. So now you will need to decide what unit you're going to use for your file size. Now, if your file size is 10,000, then the first thing you will check is whether it's greater than 1000 or not, right? If it's less than 1000, then you will just keep it in bytes, isn't it? If it's greater than 1000, but it's smaller than 1 million, then you know that you're going to use kilobytes, right? Okay, so we will need to write some code which will follow the same logic. So up to 1000, you use bytes, and then up to 1 million you use kilobytes, right? And then up to 1 billion you use megabytes, and you carry on like that. So how is log 10 going to help us? Well, if you check log 10 of any number under 1000, you will get a number which is smaller than 3. If you do that for any number between 1000 and 1 million, then you will get a number which is between 3 and 6, right? And then if you carry on, you will get a number between 6 and 9. All right, so let's try to understand the logic. So when you try log 10 on 1000, you get 3. Now, if you divide these results by 3, you'll get something consistent here. Basically, log 10 of the file size divided by 3, this will give you 1, 2, 3, and so on. So the result of this between 0 and 1000 bytes is going to be between 0 and 1. And the result between 1000 bytes and 1 million bytes is going to be 1 to 2. All right? This means that if you apply math.floor to this number, then you know the results for each of these intervals. You know that it's going to be 0 there, it's going to be 1 there, 2 there, 3 there, and so on. Now, what does this mean? Well, if we are in that range, we're going to be using bytes because it's less than 1000 bytes. And the result of this is going to be 0. So this actually matches with the index of bytes, isn't it? That's great. Now, if we are in this range, this result is going to be 1, which corresponds to the index of k, and that's exactly the units we need in this range. So now we know how to get the correct index, right? So let's store that inside a variable that we're going to call index. Now that you know the index, how are you going to convert the file size from bytes to the correct value using the correct unit? So let's start with bytes. So if you've got 700 bytes, you will just keep it as it is, right? Let's move to kilobytes. So let's say you've got 10,000 bytes. You will just divide 10,000 by 1000, and this will give you the correct value in kilobytes. Now, if you had 10 million bytes, then you would be in that range, and you would need to use megabytes. And you're going to divide by 1000 twice. So divided by 1000 and then divided by 1000. That's dividing by 1000 to the power 2. And you will carry on like that. So the next range you're gonna divide by 1000 to the power 3 and so on. So if you look at the first one, you're not doing anything, and that's similar to dividing by 1000 to the power 0, which is equal to 1. And this one is equal to 1000 to the power 1. Okay? So the formula is going to be file size, which is that, divided by math.power of 1000 to the power that you choose, and this actually matches the index. So just to make sure you got this right, I'm going to go again through this. So the index follows this calculation, and we found that for elements in that range we get an index of 0. For elements in that range we get an index of 1, and so on. And also we noticed that for elements in that range the calculation follows this logic, and we find our index right there. And for elements in that range we follow this logic, and our index appears right there, which matches with the correct index. So this is our formula for calculating the correct value, which we're going to be used in the human readable format. So the human readable format is going to be as following. So let's call this file size human, for example. So it's going to be this, followed by the unit, which is going to be the index or units at the index. So let's console.log this and see what we get. Okay, so we need math.log there instead of log. So let's try again. So here we've got 10 kilobytes for that file size, right? And we don't need this space. Now let's try another file size. Let's try something like that. And we get 5.75 megabytes. Now, to avoid long numbers like this, we can limit the number of digits in the decimal part to only 2 or 1. So you can add to fixed and choose the number of digits that you want. So let's go for 1 to see. And this looks better. So in our final code, we will set the file size variable to this value. So let's copy this code into calculate size f. So let's just add some comments. So we started here with the size in bytes, and then we're moving here to the size in human readable format. So let's delete any lines of code that we don't need. So we don't need that. We don't need that either. And instead of file size, we're going to use the file size bytes. So let's replace all these instances. So that one. And that one. So that's the index. That's the value. We can also define the units like this. And the final value we want is this one. So you're going to set the file size to that value. And instead of units index, we're going to just use the unit variable, and this makes our code easier to read. So let's test our code and make sure that everything works. Okay, so we need to start the app again because we haven't started it. Okay, and now we're getting the correct size for each of our files. So now this works for files and for folders. Right, now let's go back to our respond.js file and see which step we're going to go to. So now we finished the code corresponding to the directory scenario. So now we're going to move to another scenario where we found something, but it's not a directory. So we didn't execute that code, but it's not a file either. So we will just check if starts is file. So we're checking the opposite of starts is file. So if that's the case, we will just send a status code, which is 401. So 401 here means that we found something, but access is denied. All right, so we can't access that content. And then we're going to write something like 401 access denied. You can also log something to the console, like not a file. And you just return response.end. Now, if you go to the directory if statement, you need to make sure that at the end, you've got a return statement there. So that if you fall in that scenario, you don't execute any code that comes after that. So instead of respond.end, we're going to use return respond.end. So this means that we will end the response here, and also we are returning or using a return statement, meaning that our code is going to stop right there. Okay, so let's test our code and check that it is still working for folders. Perfect. All right, in the next video, you're going to move to the file scenario and then write code which will serve files to your users.